Now that we've introduced the idea of the unit circle and the trigonometric functions sine of t and cosine of t, let's recall some information about the equations of circles, and that will lead to something called the Pythagorean identity. So I have here drawn a picture of the unit circle. I haven't indicated the radius, but I suppose I could just by indicating what that point is right there, 1, 0. And let's draw the usual picture of some arc with an angle. And let's call this T. And let's label the terminal point x, y. Now, from previous classes, we know what the equation of a circle is. The equation of a circle is given by x minus a squared plus y minus b squared is equal to r squared, where the center here is a comma b, and the radius is r. In other words, if you have a circle with center a comma b and radius r, any point and every point on that circle will satisfy this equation. Now for the unit circle, the center is 0, 0, and the radius is 1. And so the equation for the unit circle will be x minus 0, but when you subtract 0, you don't need to write that, so x squared plus y minus 0, so y squared, equals r squared, which is 1. And now if we look back to our drawing, if we have a radian measure of t with terminal point x, y, then the x-coordinate of that terminal point is defined to be cosine of t, and the y-coordinate is defined to be sine of t. And so if I look at my equation of the circle here, and I replace x with cosine of t and y with sine of t, I get what's called the Pythagorean identity. So let's go ahead and do that, replacing x with cosine of t and y with sine of t. That has to be 1. And this will be true for every t. This is true for any angle t. And this is called the Pythagorean identity. Typically, it's not written in this form that I've marked star. We have a shorthand for writing cosine of t all squared and sine of t all squared. So the shorthand is that cosine of t squared is the same thing as cosine squared t. And similarly with sine of t squared, that's sine squared t. And so the Pythagorean identity is usually written as cosine squared t plus sine squared t equals 1. Now a brief remark on why it's called the Pythagorean identity. We used the equation of a circle to figure out the Pythagorean identity. However, you can also use the Pythagorean theorem to figure this out as well. In order to do that, we would simply draw a right triangle . One side length would be x, because that's the x-coordinate. The other side length would be y, and the hypotenuse would be 1. And from this, we see if we apply the Pythagorean theorem, we get that x squared plus y squared equals 1. So that's why it's called the Pythagorean identity. We can use the Pythagorean identity to evaluate trigonometric functions when we only know one trigonometric function. Let's see how that's done. So if sine of t is 1/3 and t is in quadrant 2, let's find cosine of t. Now, when I solve these types of problems, I like to do a visualization. So I draw a circle, and I like to draw a picture of what information is being given to me. So sine of t is 1/3. That means that, well, sine of t is 1/3 and t is in quadrant 2. So t is somewhere in quadrant 2, and the terminal point here is something x comma 1/3. And so if you draw a triangle here, a right triangle, then you know that the height is 1/3 because that's the y value, and we're looking for this x here. We're looking for x because cosine of t is the x coordinate of the terminal point. It's useful to draw the picture because it's incredibly clear from the picture that x is going to have to be negative, and that will be important. We also know that the hypotenuse is 1 because this is the unit circle, and the hypotenuse is the length of the hypotenuse is also the length of the radius of the circle. And so we can come to the conclusion here that x squared plus 1/3 squared equals 1, and x is cosine of t, so cosine squared t plus 1/3 squared is 1. 1/3 squared is 1/9, and I can go ahead and subtract 1/9 from both sides. I suppose before I do that, I want to remark that if you look at this line, this is exactly the Pythagorean theorem, or excuse me, the Pythagorean identity that we just introduced, since sine of t is equal to 1/3. So now I'll subtract 1/9 from both sides, and I get that cosine squared t is 1 minus 1/9, which is 8/9. Now remember the notation, cosine squared of t, that means cosine t squared. So if you have something squared equals 8/9, that means that the thing that you're squaring, in this case cosine t, would be plus or minus the square root of 8/9. So notice we have this plus or minus here. This is where the information that x is negative will help us out. So we know that x, or in other words cosine of t, is negative, so I will choose the negative here. If it were in quadrant 1, then this would be a positive that I would choose because the x values in quadrant 1 are positive, but it's in quadrant 2, so I know the x values are negative. That means cosine of t is negative, and so on simplifying this square root, I get that cosine of t is equal to negative square root 8 over square root 9, which is 3, and this is negative 2 root 2 over 3. And you can use the same general idea to solve other questions when you're given the information such that sine of t or cosine t is some number and you need to figure out the other trigonometric function of t. So to recap, and you may want to jot down these general steps, I like to draw a picture so I can see exactly if, or perhaps what is negative. So in this case, we were in quadrant 2, so I saw that x was negative. Then you can use the Pythagorean theorem or the Pythagorean identity that we discussed earlier to write an equation. You can solve for what you need to solve for, and you'll have to make sure that you select plus or minus based on the information that's given in the problem. In this case, we knew that our angle was in quadrant 2, which led to the conclusion that the x coordinate or cosine of t would be negative, and then you can simplify your answer.